Hello, Algebra 2 students. We are on to our next lesson, which will be operations on functions. So we're talking about composite functions. What we're going to be talking about is how we can take two functions and use them together. So the first thing we're going to talk about is composite function. So I have the erase. Composite functions. And basically with the composite functions, what we do is we take the output from the first function and we use it as the input for the second function and see what that output becomes. In other words, we take a particular x value for the first function. We substitute it in, and what that will do is it will give us a y value, in other words, a height. We take that height, whatever that number happens to be, and we substitute it in for another function, for the x value of another function, and that will then give us what we call g of f of x, which is the height of that second function. That might seem really confusing, so I think the easiest way to learn this is to do one. So let's look at this example. It says we have f of x and we have g of x, and we're asked to calculate g of f of x. So what we do is we start by taking -3 and putting it in for x in f of x. So we have -3 minus 5, and what we find is that f of -3 is -8. This is the output of our first function. So now what we do is we substitute that value in to g of x. So we're going to find g of -8. In other words, we're going to substitute -8 in for x, and we find that g of -8 equals 64. Not -64, by the way, because we're squaring. So what that tells us is that g of f of -3 is 64. That is our answer. Okay, so we took an x value of -3, we substituted it in, and we did f of -3. We got -8. We took the -8 and put it into g of x, and we got 64. So that's a composition of functions. One example. Some other things that we can do with functions are we can add, subtract, multiply, and divide them. So to indicate that we want you to add two functions, we're simply going to write this, f of x plus g of x. For subtraction, you can probably figure that one out. F of x minus g of x. Product means multiply, so we'll typically write f of x times g of x, like that. And for division, f of x divided by g of x. Okay, pretty straightforward. So now let's take a look. We have these two functions. We have f of x and we have g of x. And what we're asking you to do here is we're asking you to add them. So we're going to have 4x plus 5, that's our f of x, plus -6x plus 13. Let's combine our like terms like we normally would, and we get -2x plus 18. So that is the sum of these two functions. To calculate the difference, we have to make sure that we put parentheses around not really our first function, not really f of x, but definitely our g of x. And the reason we need to do that is when we're subtracting and we have a polynomial, you need to distribute that negative sign inside. So I'm going to turn this into plus a positive and make the 13 negative. Now we can combine our terms. So 4x plus 6x is 10x. 5 minus 13 is -8. And that is the difference of those two functions. Well, product means multiply. So let's go ahead and we're going to write 4x plus 5 in parentheses, that's f of x, times g of x, which is 6x plus 13. And you know what to do here. We're going to FOIL. So go ahead. 4x times negative 6x is negative 24x squared. 4x times 13 is 52x. 5 times negative 6x is negative 30x. And 5 times 13 is 65. And now, of course, we're going to combine like terms, clean it up as much as we can, and we get negative 24x squared plus 22x plus 65. And that answer in red, that's all we can do. Can't simplify it anymore. We have just multiplied these two functions. For the quotient of functions, we're going to divide. So we're going to have 4x plus 5 over negative 6x plus 13. Now we have to see if there's anything we can simplify there. Well, there isn't. We can't factor anything out of the numerator or denominator. We know that we're not allowed to just cancel a couple of terms. It's kind of like an all or nothing deal. So there's no simplifying we can do here. But there is one more step we have to do when we're dividing. We know that a denominator cannot equal 0. So what we have to do is we have to put the restriction on the domain. In other words, we take negative 6x plus 13 and we make an equation that says it cannot be 0. And we solve for the x value that would make that denominator 0. Divide by negative 6 on each side. And what we see is that x cannot be 13 over 6, which is 2, right? Because 6 goes into 13 twice with 1 left over. So x cannot be 2 and 1/6. Okay? So that's the only problem that you have to do that for because, again, denominators cannot be 0. So here's what I'd like for you to do. I'd like for you to stop this video. Go ahead and try the next 4 problems, okay, using f of x and g of x right here, and then come back and see if you got those answers correct. Okay? You've got this. Be careful. I know you're going to do well. Pause the video. Okay, so what I've done is I've given you the answers to the first 3, and hopefully you did well on those, and I set up the 4th problem, and I thought this was worth us going over together. So at first look, we have our fraction, and certainly what we know is that x plus 2 cannot be 0, so x cannot be negative 2. So that's the first thing. But when we look at this trinomial in the numerator, we're actually able to factor that, aren't we? You should be able to factor that into x plus 2 times x plus 5. And then we have our denominator of x plus 2, which I'm going to bundle together in those parentheses. Don't we notice that we have something common in the numerator and denominator, that being the binomial x plus 2? Well, that means we can factor that out. We can simplify it. Sorry, not factor it out. We can simplify that by reducing. So our final answer here is x plus 5 because we were able to cancel the x plus 2's out. So I thought that was worth going over. There's our answer. And now what I'd like you to do is the same thing. I want you to go ahead and I want you to try the 4 problems at the top and then the 3 problems at the bottom and see how you do. And come back when you're done and you can check your answers. Okay, here are the solutions to the first four. Um, hopefully you were able to do the sum, difference, product, and quotient um, of these functions. If you made any mistakes, please go back and fix them. Make sure you know what you're doing. And I'd like to work through the first composition of functions with you. So if you notice, this one is a little bit different because we're asking you to do f of g of x, but we're not giving you a value for x. So what we're actually going to do is we're going to take the function g of x and we're going to substitute it into the function f of x for every x value. So we will have f of negative 6x plus 13. So in other words, everywhere we see an x value, we put negative 6x plus 13 into f of x. So again, f of x was 4x plus 5. We have 4 times the x value that we're substituting in plus 5. And now we clean that up as much as we can. So distribute your 4. We get negative 24x plus 52. And then we have that plus 5 out there at the end. And we can clean that up a little bit more to be negative 24x plus 57. And that is our composition of functions. That's as much as we can simplify. Okay, so if you look at the next two examples, we're asking you to do f of g of x again. So for number 2, you're going to take x plus 2 and substitute it in everywhere you see an x value and clean that up as much as possible. For number 3, I want you to notice we're asking you to do g of f of x, which means you're going to take f of x and you're going to substitute it into g of x. So the order is important here. Go ahead, pause this video, try these two problems, and then come back again and check and see if you got the right answer. All right, so let's check your answers, see how you did. Okay, I was thinking that on number 2, I was hoping you would remember to FOIL here. Don't do FLA, don't just square the first and the last. Remember, you have to FOIL when you have a binomial being raised to the second power. Okay, and then the third one was pretty easy because we just took all of this and substituted it in for x. So the only thing we had to do was combine -2 and -1. Okay, have a great day, everybody.